Welcome, tech enthusiasts. In this session, we're diving deep into advanced generative AI, building LLM applications. By the end of this, you'll understand the core techniques well enough to start designing more intelligent, effective interactions with large language models. This isn't just theory. We're focusing on the practical knowledge you can use immediately in your projects. Let's get started on transforming your AI development skills.
Today, we kick off Advanced Prompt Engineering Techniques Part 1. This module is crucial for anyone looking to build robust LLM applications. We'll explore how crafting precise and effective prompts can significantly impact the performance and utility of AI models, moving beyond basic interactions to truly harness their capabilities. Get ready to elevate your prompting game.
To ensure we're all aligned, let's quickly recap LangChain's role in LLM app development and the workflow of generative AI. Looking forward, our learning objectives today are clear. You'll learn to analyze prompt creation, grasp foundational design principles, and master zero-shot and few-shot prompting. These are critical skills for any developer looking to build innovative AI-driven solutions. In practice, prompt engineering is your direct line to an AI model. It's about crafting the perfect instructions so the AI understands exactly what you need, making it a crucial skill in AI development. You'd use this when you need reliable, relevant, and specific outputs from an LLM. Here's why companies care. Effective prompting leads to more efficient AI interactions, saving time and resources, and that means you can unlock the full potential of your AI applications.
At its heart, prompt engineering is about effective communication with LLMs. Think of it like giving clear directions. The more precise and unambiguous your instructions, the better the outcome. In practice, teams use this because simple, clear prompts drastically reduce irrelevant outputs and improve efficiency. You'd use this when you want to avoid generic responses, and that means you can build applications that consistently deliver exactly what your users expect.
Let's see the show-don't-tell principle in action. A vague prompt like "the ocean is" gives a broad, often unhelpful answer. But by adding a simple instruction, complete the sentence "the ocean is," we guide the model to a more useful and focused response. In practice, you'd use this to avoid generic filler content from your LLM applications. Here's why companies care. Precise prompts save time and computational resources by generating only relevant information, and that means you can get to the specific insights you need faster. To consistently get the best from your LLMs, you need to understand the 4 essential prompt elements. These aren't just arbitrary parts. They're the building blocks for clear, actionable instructions. In practice, teams use these to ensure every prompt is comprehensive and leaves no room for ambiguity. You'd use this framework when designing prompts for complex tasks, ensuring all necessary information is conveyed. Here's why companies care. Structured prompts lead to predictable and high-quality AI outputs, and that means you can integrate LLMs reliably into critical workflows. Let's break down the first 2 prompt elements with a practical scenario, planning a solo trip to Japan. The instruction is your clear command, what you want the AI to do. For instance, create a Japan itinerary. The context then layers on crucial background, like specifying it's a solo adventure centered on cultural immersion. You'd use this combo to ensure the AI's output is not just correct, but perfectly tailored to the user's nuanced needs. This makes the AI's response immediately actionable and relevant.
Building on our Japan itinerary, the input data provides the factual details the model needs to work with, like travel dates and specific interests. The output indicator is equally critical, as it tells the AI how to present the information. For example, a blend of activities and flexible periods, clearly noting bloom times. In practice, this ensures the AI delivers a structured, useful itinerary, not just a random list. Here's why companies care. Defining these up front creates predictable and user-friendly AI outputs, and that means your users get a well-formatted, complete response every time.
Now, let's bring it all together. This comprehensive prompt for our Japan trip beautifully integrates instruction, context, input data, and output indicators into one cohesive request. In practice, this is how you develop robust prompts for real-world applications. You'd use this when you need an LLM to perform a complex task with multiple constraints and specific formatting requirements.
Here's why companies care. A well-crafted prompt significantly reduces the need for post-processing or regeneration, boosting efficiency, and that means you get a high-quality, ready-to-use output right away.
Let's do a quick check to see how well you've grasped the core concepts of prompt elements. Understanding these building blocks is fundamental to effective AI interaction. Choose the option that best describes the 4 essential aspects we just discussed. This ensures you're ready to apply these principles in your own prompt designs.
Moving beyond the basics, advanced prompt engineering is about fine-tuning how LLMs interpret and respond to your requests. It's not just about what you ask, but how you configure the model itself. In practice, you'd apply these settings to get incredibly precise or highly creative outputs for specialized tasks, ensuring your LLM truly understands the nuance. Here's why companies care. This level of control translates directly into higher quality, more consistent AI-generated content. And that means you can build applications with truly bespoke and performant AI capabilities.
When you're fine-tuning an LLM, parameters like temperature, top P, and max length are your levers for control. Temperature dictates creativity. A low value makes the AI predictable, while a high value encourages imaginative responses. Top P also influences diversity, letting you choose between focused or broader outputs, and max length simply governs the verbosity. You'd use these settings to tailor outputs precisely. For instance, a technical summary needs low temperature and top P, but a creative story benefits from higher settings. This ensures your AI delivers content perfectly matched to your specific stylistic and informational needs.
Beyond creativity and length, you can also control the structure and flow of your LLM's output using stop sequences and penalties. Stop sequences are like explicit boundaries, ensuring the AI doesn't ramble past a certain point, crucial for generating lists or structured data. Frequency and presence penalties prevent the model from repeating itself, fostering richer, more varied language. In practice, you'd apply these to enforce output formats in an API, or to ensure your generated content sounds natural and engaging, not repetitive. This fine-grained control is vital for professional-grade AI applications.
The temperature parameter is fundamental to controlling the model's output style. Think about what happens when you reduce the temperature. What kind of responses would you expect from the AI? This is a key concept for tailoring your generative AI's personality to specific tasks.
Zero-shot prompting is incredibly powerful. It's about asking an LLM to perform a task it's never explicitly seen before, like asking it to classify sentiment without providing any examples. In practice, you'd use this for quick, on-the-fly tasks where training data is scarce or non-existent.